Okay, the first tree I want us to focus on in this particular session is sycamore. Sycamore's scientific name is Platanus occidentalis. And if we look at the leaves, let's start with the leaves here. Okay, they are pinnately veined. Okay, and that's kind of hard to tell sometimes because if you look at it from a distance, it looks like it would be palmately veined. Here's a good one to really look at here. But if you kind of pay attention to the leaf venation here, you see that it has where it connects at the petiole there. Okay, you can see that those veins are pinnate. They're not all radiating from a central point. With palmate, all the veins would be coming off of this particular region of the leaf right here. Okay, but that's not the case with the sycamore. Okay, another thing I want you to look at here in terms of sycamore is the bark. Okay, if we look at the bark down here, it's kind of shaggy. Okay, look right here. These are flakes of bark that come off. The older it gets, the less flaky that it gets, and becomes, harder and thicker on the stem there. But the further up you go on the tree, the more of these scales that you get like this, and it just kind of peels off, and that's very typical of particularly young sycamores. And these sycamores, they were planted here in the parking lot at the school, and the reason being is sycamores are fairly hardy species. They can handle usually a lot of traffic around them. They get really big, so one day this tree will be massively huge, probably, unless something happens to it between now and then. Now, another thing that I want to point out here, the other day when we were talking about in the slides, we were talking about something called stipules. Now, this little thing growing around the stem, okay, is called a stipule. And usually stipules occur at nodes, okay, where there should be a leaf. And if you look right here, there's a bud. I don't know how well you can see this. Right here where my thumb is, there's a leaf bud. Okay, so this leaf is already apparently fallen off or never germinated to begin with. But this thing right here surrounding the stem is a stipule. Okay, here's one right here. And with sycamore, the stipule completely surrounds the stem, and it will actually leave a scar. So when this falls off at the same time that the leaf does, if you look on that stem there, okay, it leaves kind of a greenish area. Okay, and then that place where it grew right there, it leaves a scar. And that scar is something that you can use to identify this tree in the wintertime. Okay, but it's alternate leaved. Okay, we can tell that by looking where the nodes are. Okay, there would have been a leaf there, and it's fallen off. Okay, leaf scattered up the stem here. Okay, so it's alternate leaved. It's alternate branched. Okay, the leaves are simple. Okay, and toothed. Okay, so these are probably we'd call this a crenate leaf based on the way that it's toothed. Okay, so it's three-lobed. Okay, 1, 2, 3. Okay, but crenately, but it's crenate on the margin. So 1, 2, 3 lobes. Okay, and this will turn kind of a yellow color as fall comes on. So this is sycamore. Okay, another tree common to our area and valued for its wood is this species here. This is black cherry, Prunus serratna. Black cherry is in the rose family. Okay, it's alternate leaved. Okay, leaves are simple and what we call serrate. Okay, they have serrated edges along the margin there. Okay, the bark, I don't see a good place to look at the bark here because this one's covered with kudzu, but it's a member of the rose family, and it possesses toxins, particularly cyanide is a chemical that's found in black cherry, making it somewhat toxic. And depending on whether or not the year has been really dry or wet will determine the amount of cyanide that's present within it. But if you were to scratch the surface of the twigs, it puts off a very potent smell. And there are a lot of caterpillars that feed on black cherry, and that chemical gets transferred into the caterpillar's tissues, making it unpalatable for things that might want to eat it. So it's a really interesting technique that caterpillars have to be able to do that. And they do that with other things too, like milkweeds is another one that's poisonous that caterpillars use to their advantage, particularly monarch butterfly larvae. Okay, but black cherry is prized for its wood. The wood is a deep red color on the inside, and it's actually worth quite a bit of money when you can find good high quality black cherry trees. We'll see if we can find another one a little further out so you can actually see what the bark looks like on this particular tree. Okay, here's our good friend tulip poplar that you guys were introduced to a couple of videos ago. Tulip poplar, as I mentioned, and as was mentioned by Mr. Canterbury on the video that you watched about eastern trees, I pointed out, both of those videos pointed out some of the unique aspects of tulip poplar. And tulip poplar is a member of the magnolia family. I think Dave said it was in the tulip tree family, but tulip tree, magnolia, they're all in the Magnoliaceae, or magnolia family. And it is called tulip tree because of that tulip-shaped leaf. Yellow poplar is another name, but it's not, as Dave said, it's not in the same family as the actual poplars. Their genus is Populus. Okay, this one is Liriodendron. That's the name of this one's genus, Liriodendron tulipifera. And one of the things I want to point out about tulip poplar, if you recall, over on the sycamore, it had these things growing around the stem. Well, tulip poplar does as well. And remember, these things are called stipules, and it has a pair of them. Okay, it has one on each side of the leaf, or the leaf bud, which is right there. Okay, you can see where my finger is. Okay, that's where the new bud is for that particular node. Okay, and on the other side of it is another stipule. Okay, when these stipules fall off, they leave scars. And so when we come back in the wintertime and look at twigs and how to identify trees during the wintertime, you'll see the scars that are left just where that new bud is. Okay, for next year's leaf. So when this leaf comes off, it will leave a scar right there, and then just above it you'll have stipule scars where both of those stipules were. So with sycamore, the stipule completely encircles the stem. With poplar, it doesn't completely encircle the stem. Okay, you have two instead of one. Okay, and they're on either side of the stem. So that's one way to identify tulip poplar, particularly in the wintertime, is by its stipule scars. Alright, so here we have a pine tree. This is Virginia pine, Pinus virginiana, and if we look way up there, we'll see the top of it. This is actually a pretty old tree. It's not often that you see Virginia pine this old, but you can tell that this is a more mature woodland area. There's some pretty large trees scattered around in here. We'll look at a big one a little further over here in just a second. But it tells me when I look around at the trees and the age of the forest over here, this part was cut way earlier than the rest of it. I mean, just look in here, you can see there's a few larger trees. There's not a lot of pine in here. It may have something to do with where we are on the slope. Okay, but it's just not as immature as some other areas of the Ditmer Watts trail. A lot of hardwoods in here. And you can actually see on the ground some of these logs here. These are pine trees that have already fallen. So most all these are mature and either ready to come down or have already come down, because they just don't live very long. Most of these Virginia pines don't live more than about 75 years, if that. Okay, most of them will fall out before that. Okay, but that's what you're seeing. These logs are mostly all Virginia pine. So these are mature and will be ready to come down fairly soon. Alright, now this tree here is quite possibly the biggest tree in the entire Ditmer Watts Trail Park. Okay, look at how far up there that goes. Okay, this is a white oak. Okay, Quercus alba. Okay, and white oak, as Dave Canterbury mentioned, is a very, very important species of the forest. On many years it's covered or loaded with acorns, and those acorns are a very important mast food for deer and turkeys and things like that. They usually get them pretty fast because white oak acorns will rot before a lot of the other ones do. They don't keep very long, whereas some of the other ones will stay edible for a little while. These tend to rot pretty quick after they fall to the ground. So a lot of things get them very quickly while they taste pretty good. But you can, all the acorns that fall from oak trees, the white oak acorns are the best for human consumption. They have the least number of tannins in them compared to some of the others. And to get the tannins out, you actually have to soak the acorns, and that helps to flush out a lot of those. And then you can take those acorns and you can actually grind them up and make a paste, which can then be turned into a bread. But this tree, I would say, is probably close to 3 feet in diameter. So it's quite large for what you see in the forest here at Ditmer Watts. It's got a couple of places in it. So if you look up a little higher there, it's got that big outgrowth there. Okay, that's called a canker. Okay, and most likely this tree has been wounded at some point in time. Okay, some people call them burls, and usually, like wood carvers and things, will take the wood that's in the burl, which is going to be really interesting looking and be real curly and have a lot of interesting shape to it. They'll use that to make tables and things like that. You cut across that, and it would be really interesting. Okay, but what happened? This tree at some point got wounded. And so in order to heal the wound, it grew new tissue around it and sealed off the wound, and it left this permanent scar on the tree. And it pretty much goes all the way around. Okay, but what a really cool tree. And then it kind of stops right there. So there's no telling what it was that damaged the tree. Okay, but this tells us a little bit about what this tree's been through. And if you look down here, okay, you've got other things like this right here. Okay, there was probably maybe a limb or something here, a branch that broke off. Who knows? This is such a large tree. It's really kind of hard to tell, but it looks healthy in general, which is nice. I don't see any mushrooms or anything like that growing up from around its root collar, which is a good sign. So that means that there's nothing dead in there. Now the inside of this big tree could very well be hollow, because a lot of times older trees will have hollow trunks where the wind has shaken them and broken loose that heartwood from the sapwood, and so sometimes these will hollow out. But as long as it's got intact vascular tissue, it'll stay alive until it's ready to kick the bucket. Okay, there are a few acorns here on the ground. Okay, here's a white oak acorn here. Okay, these are kind of elongated, and it's got this cap on it. Okay, so this is white oak, and you can always tell white oak because of that. They're kind of an oval shape, and these will turn brown after a few days of being on the ground. But if you're going to eat these, now would be the time to do it while they're still rather tasty. And there's some other acorns laying around in here too, some scarlet oak acorns, and I'll show you some of those when we get a little further up the trail. So down here on the ground, it's a little easier to identify some of the oaks. Okay, particularly, let's look at this one. This is, again, white oak, and these are all seed trees. Okay, from this great big white oak that is here behind me that we were just looking at, all of these came up from the acorns that big tree dropped. So you got all these little saplings coming up, and they're waiting on their parent plant to die. Okay, so that they can someday dominate the canopy. Okay, all these are mostly about the same age. If you look at their heights, okay, they're all, and their diameters, they're all about the same age. Okay, but these are waiting to replace the larger tree. Okay, now you can tell white oak, okay, when we look at the leaves, okay, the lobes are rounded. Okay, whereas if it were one of the red oaks, okay, these would have little points on them. I heard an interesting thing today. Whites, referring to the settlers, had round ammunition when they settled the land. Okay, so white oak is round. Red oaks are pointy because the red man, or the Native Americans, and I know they don't like that term red man, but for sake of the rhyme it's useful, but they shot arrows, and so the red oaks are pointy. Okay, and we'll look at some of that in a minute. The oaks are divided into two groups, the white oaks and the red oaks, and depending on that leaf differentiation is kind of how you separate them out. White oaks include things like Quercus alba, also chestnut oak, which is Quercus montana. Both of those species have those round lobed leaves. And then some of the red oaks would be like northern red oak, scarlet oak, southern red oak, things like that. And we'll see a couple of those other ones as we walk up the hill. All right, so here's something I ought to point out. So this is a stump from a Virginia pine that has been just kind of left here to rot. But these old stumps, they don't rot very well. They kind of like to hang around for a while, which is beneficial because I can kick this thing and break it loose. Okay, I can kind of tear this thing open here, and this gives me something really useful. Okay, so I'm going to pull this apart. There we go. So if you'll look, based on, let's see how steady I can hold this, or maybe I'll just set it right there. All right, so Virginia pine is loaded with resin. It doesn't have as much as pitch pine, but it's got a lot. And that resin is flammable. And so what I've got right here, I've got a good source of kindling. You can take this wood, a lot of old timers call it fat wood or fat lighter, okay, because it's loaded with resin and turpentine. And that turpentine crystallizes inside the wood there. And that's what actually is a big component of that resin. And that's what gives it that gives pine that smell, is the turpentine in it. But turpentine is very flammable. And the turpentine crystallizes in there. It actually makes these stumps pretty hard. But you can go in and you can extract this, and you can kind of peel away the rotted wood and expose the drier fat wood, and use this to light a fire that will burn for a good little while until you can get some larger fuel on it. But it really works quite well. But this is a pine stump, okay, Virginia pine, and we're looking at an example of how to get fat wood. This little area right here where my finger's at, okay, I can actually feel that resin, how sticky it is in there. Okay, so this is good stuff right here. You can kind of, if you were to get a little knife or something, you can kind of pull that out of there, and it makes really good lighter material. All right, let's talk about Virginia pine a little bit more for a second. So there's a small Virginia pine here, and Virginia pine, the way to identify it, aside from that bark that it has, it's kind of scaly and shaggy, is it has 2 needles per bundle. Okay, so let me pull a bundle off here, because I don't know how well you can see it. Okay, so 2 needles per bundle. Still don't have it exactly how I want it. Kind of hard to hold a camera and hold something this small at the same time. See if we can get it in focus. There we go. 2 needles per bundle. And also notice how the needles are twisted around. Okay, so that's another way to identify Virginia pine. Twisted needles, and 2 per bundle. They're always kind of thick. Okay, and if you were, you wouldn't eat these or make a tea out of them like you would with white pine. Okay, they're not. They would be pretty astringent as far as taste and everything goes, and they're just not as palatable as white pine. But this is Virginia pine, and it is all over the place. And see, we're moving higher up on the ridge now. We're starting to pick a little bit more of it up. So it tends to be a lot more, if we look up in the canopy, a lot more Virginia pine up here than down in that little valley where we were before. There's a yellow pine right over there, or shortleaf pine is another name for it, and it looks a little different than the Virginia pine. Its cones are a little bigger and its needles are longer, but that's what that one is over there. Okay, now we've got a different oak here. Okay, this is, I believe, scarlet oak. I don't see any parent trees around. This is really hard to tell, but there are quite a few scarlet oak around. It could be a northern red as well, but this is being more down in the Piedmont. Scarlet oak tends to be a little bit more common than the northern red oak, which is more of a montane species. But notice the difference in the leaves here. So look at the points, okay, on the lobes, okay, those little points there. So instead of being rounded, okay, it has those little dentate or little points there. So pretty cool. The oaks are all alternate leaved. Okay, so if we look at this stem, okay, there's all alternate. Okay, here's a couple more. You see that alternate leaf arrangement. Okay, the leaf margin is entire. And if we were to flip it over on the back, okay, another characteristic that these oaks have is that they are what we call glabrous on the back side and on the top side. Okay, on the underneath and on the back, they are glabrous, and glabrous means that they have no hairs. Okay, but there are just some faint hairs within the veins there, right there in between the connection with the midrib and this lateral vein here. There's some tiny little pubescence in between there, in that connection point, and that's one way to tell some of the red oaks, because they will have that little bit of pubescence in there. Red oaks, scarlet oaks, their acorns tend to be more bitter than those of white oaks, but they hang around for a little bit longer, giving the deer and the turkeys and the squirrels and so forth more variety for a longer period of time. Now, we've talked a little bit about red maple. This is a large red maple here. I want you to look very carefully at the bark so that you see what these trees look like, especially a mature red maple. And I've got a little bit of backlighting here, so it's kind of problematic with the camera, but I want you to really look at that bark. Okay, it's kind of white and stripedy, if that's a word. Okay, the older it gets, the more scaly it gets. Okay, younger ones tend to be have more slick bark than this one has. Okay, and notice down at the bottom, what's going on here? Okay, this is kind of bizarre. Okay, so there's all this growth coming up here. It basically looks to me like this maple probably came up from a stump. So at some point this was cut, and this maple here, this is the main stem is the one that survived. All these other little things coming up, these are what we call, this is called coppicing, and these are just what we call regeneration sprouts or sucker sprouts that come up from the root collar, which is there under the ground, that come up to try to replace the original tree. Okay, but clearly there's a dominating main trunk here. Okay, but I want to point these out because some might say, well, this is a shrub because it's multi-stemmed, but really it's not a shrub. These are all just sucker sprouts that are coming up from that root collar. Okay, but this is a mature red maple. Makes good firewood, burns kind of fast. Okay, but this is about as big a red maple as you'll see in the southern Appalachian forest.